Hello, I'm going to show you my Rover SD1 1985 Vitesse 4.6 V8 twin plenum. Let's have a look around it. I'll start it up for you. I've got a Bowden cable here attached to my cold slow running. This is a gear knob off a Rover 75, and here I've modified the clutch pedal so that I can get my left shoe underneath it. Let's have a look under the bonnet. It's 4.6, 280 cubic inches, and it's out of a Land Rover, and it goes straight in, but the front section here to the front is SD1 because it's got a distributor. The reason I use Bowden cable is because the thermostatic vane that goes across there takes too long, and you end up doing about 1500 RPM for 5 minutes before it slows down. So I blocked it off here, I blocked it off down there, and just about everywhere. So the only control on the slow running when it's cold is here on the Bowden cable attached directly to the throttle shaft. This is the warm slow running or idle screw. This is the cold start injector, which I don't use in the summer. And here's the breathing. Rather old fashioned, but it does pass the MOT, but I do get a spectacular backfire sometimes. I think it's something to do with this thing, if somebody can tell me. And I'm running a duplex roller cam timing chain. It's got headers, 4 and 2 into 1 each side, and standard valves, standard springs, but it's been ported and polished. Let's have a look round the other side. Do you know why a V8 goes blub blub blub? Because the firing order is left, right, left, left, right, left, right, right. So you get 2 adjacent firing pulses per cycle on each bank. So that's why it goes blub blub. You can minimise that effect by putting a balancing pipe in the exhaust system. Here's the throttle pot I put on. This is the original one. Can you see there how it goes round? That's the original one. I cut down to there. I mounted this one on off a Rover 1.8 diesel, I think. 5k ohms over 80 degrees. Rather difficult to do. And then I mount this termination there so that you've got a nice clean carbon track. You can't buy the originals, and you can still need this former to rotate it to get your 0.325 volts. Here's the distributor I used, which I had on the bench. Put a new brass bush in it so that the shaft doesn't wobble about in there, and different springs, and I stretched the second spring a little bit so that it stays on the first spring for a longer time, giving it more advance for a longer time until the second spring comes in operation. And I modified the total advance by grinding the turret. This is what makes it go fast, the extra advance that you introduce into the system. These electromechanical systems worked well in the old days, and I haven't moved on yet. This is the belt which I aligned very nicely on the bench, and this belt also. This is a 3.9 pulley, and the power steering pulley is mounted in front of the damper on this engine, and the power steering pump is mounted ahead of the power steering bracket. This is a linkage of the single plenum which I adapted to the twin plenum because in case I wanted to swap plenums. It won't go any faster with this twin plenum because you're not drawing that much more air. In fact, it's only really pose value. It's only really for pose value. Let's have a look around the back pose. And here I've got two adjustable pump up Monroe shockers, independent. Now if you have any imbalance on the rear suspension like I have on this car, you can correct it with the pump up shockers by pumping up one shocker more than the other. If you just have one gauge, you will perpetuate the imbalance. Let's have a look at some pictures I got how the engine went in the car. So this is the Sump, SD1 Sump. I put a couple of dents in there with the blunt end of a 1/2 inch extension socket. It's only the front one where the front crank pin goes in, and I chamfered the big end nuts so that when they go in the dish you've got another 2 or 3 millimeters. I put a frame around the sump so that the bolts there don't pinch the gasket and make it leak, and I elongated the holes on the inlet manifold so that the bolts don't bind, but of course it does depend on how thick the cylinder head gaskets are. I buffed up the rockers so that they slide over the top of the valves nice and easily, and there's one I didn't attend to. And there's the I wrote out how to set up the distributor on an engine built up from scratch. Let's have another look at the Rover. It's got 225 60/15 there and 205 60/15 on the front. The front anti-roll bar is mounted with these on the front with the modern nylon bushes, and I made up some bits and pieces for the connection to the lower wishbone on the front to make it more rigid for the steering and suspension. What EFI am I using? Well, it's the original 1985 Rover Vitesse 4 ohm system. There we are, 4 ohm injectors. I've not moved up to the 16 ohm injection system. It works fine on 3.5, 3.9 and 4.6. I'm running a 4.2 camshaft with a lift of 0.416, and when I took the camshaft out of this 4.6 engine it had a lift of 0.416, so it wouldn't surprise me if the 4.2 and the 4.6 camshafts are identical apart from the front termination. I've got a duplex roller camshaft, duplex roller cam timing chain, and the car is making about 300 pounds-feet at 2,500. How's it go? Well, it goes like stink really. It's far too powerful for the car, and I only really drive it like a 3.5. Occasionally I'll give it some stick in the intermediate gears, but I don't use it at top speed, and of course you've always got to keep an eye out for the fuzz. It's an old car, so I don't want to stretch the gearbox and back axle too much. I don't want to hear a bang. I'm sure the engine is too powerful for the gearbox. Now this car used to be a Vandenpla, so I replaced the automatic transmission with a 5-speed manual, and it used to run there for 2.85 diff, and I changed that diff to a 3.08. I did run it for a time with a 285 diff and 0.79 fifth and a 3.5 donk, but it was doing about 36 miles an hour per thousand in top gear, which was ripped too high, so I changed the axle to a 3.08, and now I'm running about 34 miles an hour per 1,000 in top. I'm running 80 MTF oil in the gearbox, very nice, from Halfords, and a standard clutch and a lightened flywheel, slightly lighter than the lightened flywheel of the Rover Vitesse, which I had made up in the 80s at Selly Engineering in Oxford, and I still kept it. So the standard clutch won't hold when I give it some stick. And what did I do with the 2.85 axle in 2001? Silly me, I dumped it. It would have been fantastic for this car with 0.79 fifth and a 4.6 donk, but that's what you do sometimes. I didn't think it was valuable at the time. In actual fact, this gearbox has not got a 0.79 fifth, it's got a 0.73 fifth. Two special gears will fit in. They're 3mm wider than standard, and you have to make up a spacer. So 0.79 to 0.73, I'm 7% up on fifth on this gearbox. How does it compare with the Lexus? The Lexus is a V8 4 litre quad cam, 270 pounds-feet at 4,400. Very similarly geared to the Rover, 35 miles an hour per 1,000 in top, with a 0.7 top 4-speed box, and I did have 3.63 diff on here, but I changed it to a 3.27 out of a Mark IV LS400. We transferred the whole of the subframe at the back and the prop lined up, and so now I am 11.5% up on all gears. What this means is at 70, indicated 70, I'm doing 80, and at an indicated 30 I'm doing 34. Don't I know it, when they zapped me behind my back going up the hill, and it cost me £100. So I'm very pleased with this conversion. The Rover really has the edge on the Lexus simply because there's no substitute for CCs. You can get all the miles per hour per 1,000 from the technical page on the transmission page on the Rover SD1 website. Put in the parameters and it'll calculate it for you. It also means that I can get 33 miles to the gallon out of this Lexus, which is 8.5 litres per 100 kilometres. Let's have a look at another engine I've got in the garage, because that 4.6 is too powerful, and I've got a smaller one to put in. It's 4.2 out of a Land Rover LSE. I don't know why they called it 4.2, because it's really nearly 4.3, and is 4275 cc's. 94mm bore, 77mm stroke. The stroke on the 4.6 is 82mm, and the crank doesn't hit the sump on this engine. I've got a new water pump on it, and the fan is off a Citroen 15-inch diameter fan instead of a 16-inch, and I mounted it on whatever you call this thing. The damper is regular 3.5 damper, and the power steering system is also conventional. The pulley is mounted behind the damper on that engine. The stroke is 3.03 inches on this engine and 2.8 inches on the 3.5. So I think they use the same crank casting. They managed to get another tenth of an inch out of it for the 4.2. This is the 3.5 I took out. It's got Rover P6 pistons. There's hardly any dish in the crown. 10.5 to 1 compression. And when you assemble the engine, you've got to assemble 4 pistons with the arrow pointing forwards on the con rods, and 4 pistons with the arrow pointing the other way. Or this has got no arrow, this has got front written on it, so all the fronts have got to, 4 fronts have got to face forward and 4 fronts have got to face backwards. When you assemble it, they'll all face forward, because this is because the gudgeon pin is offset 1mm on these 10.5 compression pistons. This is to minimise the bore wear on a power stroke. The shells are the same for the 3.5 and the 4.2. This is a single plane manifold with the 4 ohm injectors, and this is the throttle pot of a 4.6. 5k ohms over 80 degrees, and put this termination on because I had a spare wiring loom. If this was a 3.9, it would go straight on top as well with a 3.9 block. What starter motor am I using? I'm using the later 4.6 starter motor. If you heard this engine start up, you might have been able to detect that it was not a Bendix drive. It was a clutch drive. And I've got a 4.6 starter also on this engine. There they are. There's the old Rover one, the Bendix drive, and there's a new one, the clutch drive, 4.6. Look, you can see the solenoids are nearly 90 degrees apart, so that this one, when you mount it on, the solenoid comes at the bottom, and this one, when you mount it on, the solenoid would come at the side and foul the exhaust manifold. But you can modify them to fit on, but it would take a YouTube video for me to show you how to do it. It's a good modification because they're more efficient, and I enjoyed doing that one. Now, there's only one more thing to say. This Rover, it might need a new respray. It might need a new sunshine roof. It might need a new sunshine roof because that one leaks water. It might need a new headlining. But I'll give any other Rover SD1 owner a run for your money.